Hello, I'm delighted to be introducing you to GRM's new product, OptiAssist for Simcenter 3D. OptiAssist in Simcenter 3D provides workflows for design optimization, unlocking the capabilities of Nastran's optimization module. And specifically, in version 1, OptiAssist will provide workflows for composites, castings and mouldings, and shell assemblies, but this will expand with the future developments of OptiAssist. Now, for those people that aren't familiar with GRM, we're a CA software and services provider with a core focus on the practical application of design optimization methods. Having supported other solvers since 2004, OptiAssist is GRM's core optimization workflow tool and has provided many businesses with clear product improvements through enabling powerful optimization methods. To demonstrate this success, GRM are very proud to have supplied OptiAssist to the Formula 1 team, winning the Drivers' Championship for 13 of the last 14 years, something we very much plan to continue. Available in version 1 of OptiAssist for Simcenter 3D are 4 specific optimization trails. These are composite ply placement, efficient laminate optimization for existing laminates, component and assembly gauge optimization, and casting and moulding thickness optimization. So let's take a brief look at OptiAssist in action. So we'll start with one of the most powerful features, which is the ply placement development capability for composites. And we'll do this with a very simple box beam under bending. And we'll do this because we can understand quite clearly what the real answer is. We have a box beam under bending. We want to have tapered thicknesses of 0-degree fibers on the top and bottom surfaces to maximize the stiffness. So let's see if OptiAssist can actually achieve that same answer and demonstrate how it works. One of the key strengths of OptiAssist is the way it allows the user to very efficiently divide a model up into sub-patches with different methods, either geometry, features, group-based or user-based subdivision. For this example, we'll just cut the model into sections along its length. And having done this, we can see how OptiAssist has developed that tapered thickness of 0-degree fibers on the top and bottom. So let's look at something more complex. When we do this, we can really start to see the power of the ply placement method, identifying the placement, most efficient placement of fibers and their orientations. And we can do this while considering complex loading requirements for stiffness, strength and vibration. And this is really where the power of design optimization can start to influence design and improve designs and provide performance, mass or cost savings in developments and really maximize that return on investment. Of course, sometimes you have a more mature laminate and you don't wish to change your ply shapes or your ply patterns, and that's where the efficient laminate optimization processes in OptiAssist for Simcenter 3D can also be applied. The user can define change to the number of plies and their orientation in a laminate and optimize those. And then following completion of optimization, the global layer can be directly updated based on that optimization result. Of course, OptiAssist isn't just about composites. We'll take a look now at a large pressed assembly. In this case, a good example is an automotive body in white. And for such an optimization problem and development problem, OptiAssist allows users to very quickly define the design data, manage the design data, and submit the optimization for hundreds of panels, managing their design thickness. And there are different rules available for minimum and maximum thicknesses or percentage changes or combinations thereof. And as ever, these results can be interrogated inside Simcenter and the FEN model data directly updated based upon the optimization results. Finally, we'll take a look at expanding that gauge or thickness optimization into components where physically we can vary the thickness of the parts, so examples such as castings and mouldings. And for these, we take advantage of the subdivision process available also in the ply placement for composites, where the user can choose one of the 4 methods available: grid-based, feature, geometry or manual user patch creation, to subdivide their designs, and then optimize and understand the most efficient thickness distribution of the part. And as ever, the model data can be directly updated from the optimization result. Okay, so that's a brief introduction to OptiAssist for Simcenter 3D. More detailed videos are available for each of the functions that I've discussed. You can find these on our media channels. And to find out more about OptiAssist for Simcenter 3D, or try it out for yourself, why not contact GRM, talk to one of our engineers, and have a go for yourself. Thank you very much for listening.